Hello and welcome to my presentation here at the Achema Pulse about extending OPCUA to the field. My name is Peter Lutz. I am the responsible director for the Field Level Communications Initiative as part of the OPC Foundation, and this initiative is responsible for the development and the creation of specifications for extensions to the OPCUA technology to meet the various use cases and requirements for automation applications, including the field level. I want to first talk a little bit about some of the key challenges for industrial automation in the context of digitalization and the digital transformation. We still have today a quite strict separation between IT and OT technology. But it's clear that if we want to support the various use cases of, for example, Industry 4.0 or the Industrial Internet of Things, we have to exchange information across all these different levels inside a factory, inside a plant, and even beyond. And therefore, we have to come up with solutions that support the IT-OT convergence. What we also recognize is that today we have quite different solutions, different products, and even different technologies being used in factory automation and process automation. But certainly the requirements are quite similar, if not to a large extent identical. And this is why in future we have to strive for a harmonized approach that is not, let's say, distinguishing what kind of industry or what kind of vertical products or solutions are being used for. And probably one of the key challenges is the huge diversity that we have with regard to protocols and data models, especially when we look at the field level, because there we have all the different field buses and real-time Ethernet protocols. We have still digital analog interfaces. And looking then at the data modeling, we also use different device profiles just out of historical reasons. But this is all making the life complex and difficult, especially if you want to analyze data, if you want to derive certain strategies out of the information that you collect from the plants, from the factories. And this is why we have to come up with solutions that support the so-called semantic interoperability. Now, there are different solutions how to improve the vertical integration. I have here a graphic from the Namur Open Architecture, the NOAA, which is not dissolving the classical and established automation pyramid, but is adding a so-called second channel based on OPCUA in order to bring up information from the process, from the production, up to the edge and to the cloud. Even this is beneficial because existing solutions can be kept and the connectivity is improved by the second channel. At the same time, it's clear there are some disadvantages. You are adding an additional second channel, so the devices need to support an additional protocol, increasing somehow the complexity. And this is also only a unidirectional path from the process up to edge, up to cloud. Now, the approach of the OPC Foundation with the launch of the Field Level Communications Initiative back in November 2018 is to extend OPCUA to the field level so that it fully scales from the field up to the cloud, and not only vertically in both directions, but also supporting the horizontal integration, the horizontal communication. With this approach, OPC Foundation targets to convert the classical automation pyramid to a much more universal and flexible information network where you can have direct connectivity between devices and controllers and software applications, independent whether they are located in the field, in the edge, or even in the cloud. Now, OPCUA today is already used in many different application areas. You find here some examples listed with the numbers 1 to 4, secure remote access, local OT communication, and also, for example, cloud integration. The Field Level Communications Initiative is now extending the use cases to also cover controller to controller and controller to device, listed here with the numbers 5 and 6. And this is also including device to device. To support these use cases, the OPCUA framework is being extended with features and functions for field exchange. This is why we name these extensions OPCUA FX. And this includes, for example, extensions to support functional safety, to support real-time data exchange, including deterministic transport. It also defines features and what we call facets for motion control for remote IOs, and also the connectivity to field instruments. Let me talk a little bit about the initiative itself. The initiative is supported by overall 27 member companies that are part of the so-called steering committee. So these companies bring in additional resources, financial resources, but also manpower and the expertise. Browsing through the logos, you see that all the big players in industrial automation are supporting this initiative. So we have, for example, from the US, the companies Emerson, Rockwell Automation. We have from Europe the companies ABB, Siemens, and Schneider Electric. And looking to Asia, we have the big players out of Japan with the companies Mitsubishi, Omron, and Yokogawa. The technical solution that is being elaborated is supported by more than 320 technical experts that are coming from more than 65 member companies of the OPC Foundation. This makes us really proud that this initiative is getting such a strong support from the industry all over the world. Now, first of all, I want to highlight that in order to support industrial interoperability, you need to have standardization at all the levels that are listed here on the slide. So you need standardized network access, you need standardized protocol, and you need standardized data semantics. The solution for field exchange, OPCUA FX, is built upon existing OPCUA technology with the built-in security, with the information modeling, with the client-server services, and the publish-subscribe extensions. The technical working groups of the FLC initiative are then extending the information models to support the various automation components, including offline configuration and including common behaviors, for example, to set up connections between the various automation components and to do the bootstrapping of a complete system. On top, we then have the various extensions and features to support the various application areas and the various device types. So there are facets for functional safety, for motion control, for instruments, for IOs, and so on. And the concepts are done in a way that existing device companion specifications can be integrated. So this is where we can, for example, integrate the PADIM information model or the MDIS or the DEXP and all the other companion specifications that are elaborated through the numerous corporations the OPC Foundation has all over the world. Now, if we look at the lower levels, we are relying on various IEC and IEEE standards. Very important for us are especially the Ethernet standards out of IEEE, with the certain variants, for example, the Ethernet Advanced Physical Layer APL that is being launched in these days at the Achema. Very important to bring Ethernet to the field in the process industry, but also Ethernet TSN to make transport deterministic is very important, as well as other communication standards that are being developed by standardization organizations. We are defining two communication profiles to map the information models on the higher layers to the underlying network and transport protocols. So we are supporting a UDP/IP protocol for a routable, flexible protocol, as well as supporting a so-called direct layer 2 mapping when it comes to a more efficient or highly efficient communication, for example, inside a machine for distributed IOs or high-speed motion control. The concept is also created in a way that we can easily adapt to other upcoming communication standards and technologies. Important to mention is especially 5G. We have established a cooperation with the 5G ACIA to support 5G inside the OPCUA framework to also support wireless communication. And in future, we will also extend to other wireless standards such as Wi-Fi 6, Wi-Fi 7. Finally, I want to highlight that we work on conformance tests for the various automation components in order to ensure high compatibility and a high level of interoperability across the various vendors. A key technology for OPCUA in the process industry is the Advanced Physical Layer Ethernet APL, as already mentioned, because this is bringing Ethernet to the field even in hazardous areas. And because APL is transport agnostic, it is supporting different industrial protocols, including OPCUA. And this is why the OPC Foundation has become member of the APL initiative a few months ago to support the further development of the technology and also to jointly promote Ethernet APL with other standardization organizations. Now, talking a little bit about the current status of the project and the achieved results. The first specification release, the so-called Release Candidate 1, has been completed, consisting of 4 parts, parts 80 to 83. And these specifications are currently being used to do prototyping and to create test specifications as well as test scripts for the certification tool of the OPC Foundation. And furthermore, these specifications are laying the foundation to do specification enhancements for the additional use cases, controller to device C2D, including also device to device D2D in the next step. What I already can announce today is that we are currently preparing a controller to controller interoperability demo based on this RC1 specification release. The demo is planned for end of November at the SPS Automation Show in Germany, and we expect more than 15 vendors and more than 20 prototypes to be included in this controller-to-controller demonstration system, showing the exchange of process data, real-time data, even safety data between controllers of different manufacturers. Now, with this slide, I want to explain a little bit the migration path with OPCUA from existing systems to support in future also OPCUA in the field level. You see here the classical solution, having controllers that use OPCUA to connect up to the edge, to the cloud, to the MES ERP systems. And we have the field buses that connect the controllers to the various underlying field devices. Now, with the controller-to-controller specifications developed by the FLC initiative, we allow the horizontal integration and horizontal communication between controllers of different manufacturers. So this is the initial step. And then by bringing OPCUA down to the field devices with the use cases controller to device and device to device, we then have OPCUA as one consistent and one standardized interoperability communication solution that is fully scaling vertically as well as horizontally. Now with this slide, I want to quickly summarize the content of my presentation. I wanted to show to you how the OPC Foundation with its field level communications initiative is extending OPCUA to support also the field level. And with this approach, there is the possibility to finally convert the traditional automation pyramid to a very universal, to a very flexible information network where we can have direct connections between the various field devices, controllers, different software applications, independent whether they are located in the field, in the edge, or in the cloud. And the solution is to extend OPCUA to meet the various use cases and requirements in factory and process automation with the support of different underlying technologies and standards such as the Ethernet Advanced Physical Layer, Ethernet TSN, 5G, and in future also Wi-Fi 6, Wi-Fi 7, and whatever comes up. I'm now coming to the end of my presentation. I want to thank you all for your attention. In case of any questions, feel free to contact me. You have here my contact details, but you can certainly also look at the various links that I'm providing here to identify related material. We have brochures, we have recordings, we have slides available. So please have a look, and thank you very much again.